Okay, we solve one problem related to minimization. So here we write a function, cost function c equals to 5x1 plus 10x2, and we have following constants x1 minus x2 greater than equals to 1 minus x1 plus x2 greater than equals to 2, and x1 and x2, the natural constants are always there. So as I said, first of all, this is the problem of minimization, and we will try to convert it into the problem of maximization, and then we will apply simplex method. In problem of maximization, we always be given a profit function and all the constants are in less than equal form. Then we say that this is a problem of maximization. Okay, so now we write it in a matrix form as it is, starting from the constants. So we say that a equals to coefficient of x1 is 1, so here it is 1, coefficient of x2 is minus 1, so here it is minus 1, and then constant 1. Coefficient of x1 is minus 1, coefficient of x2 is 1, and this is 2. Now coefficient of x1 is 5, coefficient of x2 is 10, and coefficient of c is 1. Now we take its transpose. If we take its transpose, we interchange rows with column. So this first row will become first column, second row will become second column, third row will become third column. Okay, now we write it back into the equation form, and we will see that this first equation will be y1 minus y2 less than equals to 5, because we took its transpose. So these greater signs will be converted into the less than signs. So from the second row we can read minus y1 plus y2 less than equals to 10. And similarly, from the third row we can from this third row we can read the profit function p equals to y1 plus 2y2. So now this is your standard problem of maximization. You can see we are given profit function like this. All the constants are in less than form. Now we can apply simplex method on that. And to do so, what we do, we add the slack variables y1 minus y2, we add slack x1, so it will become 5 equals to 5 minus y1 y2 plus second slack, so it is 10. And the profit function, as I said, we write it in this form. We bring all the variables to the left side, equals to 0. Now we write it in a matrix form with basic variables and non-basic variables. So here you can see that from the first equation, y1 minus 1 x1, there is no x2, there is no p, equals to 5. From the second equation, minus y1 y1, there is no x1, there is x2, there is no p, equals to 10. From the third equation, minus 1 minus 2 0 0, there is p, and equals to 0. Now our basic variables are like here, this is y1 y2 x1 x2, and this is p. We write here our basic variables. Basic variables are those variables which we have 1 and rest of the elements are 0. So x1 is the first basic variable. Similarly, in x2, you can see that there is 1 and rest of the elements are 0. So x2 is second basic variable. Similarly, p is our third basic variable. Okay. Now we draw a line and we see that the most negative number in the bottom row. So this -2 is the most negative number. So this is our pivotal column. Now we divide the extreme rightmost column with this pivotal column. This is negative sign. We cannot divide with the negative sign. Normally it is like this. So we don't consider this option because here it is negative. The next is we divide 10 by 1. So this is the only positive number. So this is the smallest quotient. So this is our pivotal row. And this is our pivotal column. Now with the help of this one, we will make 0 above and below. Okay, so to do so, what we do, we apply the operations. I write this matrix once again for your better understanding, so it would be easy for you. So the matrix was 1 minus 1 1 0 0 5 minus 1 1 0 1 0 and 10 minus 1 minus 2 0 0 1 0. So this was our pivotal element. So we add row 1 plus row 2 and row 3 plus 2 times of row 2, and it will give us 0 0 1 1 0 and 15 minus 1 1 0 1 0 and 10 minus 3 0 0 2 1 and 20. So here you can see that this is our basic variable x1, and x2 was shifting variable, moving variable, which we can say y1 and y2. Now again we will see in the bottom row, you can see in the bottom row the most negative number is -3, the only -3. But in this column, this is very interesting thing, and you need to understand this. We don't have any positive number. We cannot divide 15 by 0 in order to identify a pivotal row, and we cannot divide 10 with -1. So the -1 is the bottom row, indicates that the column 1 is the pivot column. Since no positive element appears in the pivot column above the dashed line, we are unable to select a pivot row. We stop the pivot operation and conclude that this maximization problem has no optimal solution. According to the theorem 1 now applies that the original minimization problem has no solution, because theorem 1 says that if the maximization problem has a solution, the same solution would be continue for the minimization problem. So I solve one more example from the book, and where we have different constraints, and the cost function is given like 6x1, 5x2, 4x3, 8x4, and the constants are x1 plus x2 less than 700, x3, x4 less than 900, x1 plus x3 greater than 500, x2, x4 greater than 1000. This is a problem of minimization, because here some constants are in less than form and some constants are in greater than form. So first of all, we will convert all the constraints in the greater than form by multiplying with the negative sign. If we multiply this row, this constant with negative, we will multiply this constant with negative, so that all the constants should be in maximum form, like in this form. Then we will convert it into the maximization form. So if we multiply first constant with negative, it will become -1, -2 greater than -700. The second one will become -x3, -x4 greater than -900. Third constant is already greater than 500. Fourth constant is already greater than 1000. So now we will write it into the matrix form, because all the constants are in greater than form and we are given a cost function. So if we write it in a matrix form, it will be -1, -1, 0, 0, -700. The second constant will read as 0, 0, -1, -1, -900. The third constant is 1, 0, 1, 0, and 500. And the fourth constant is 0, 1, 0, 1, 1000, and the last one is 6, 5, 4, 8, and 1. Now we take its transpose. Column rows will become column: -1, -1, 0, 0, -700, 0, 0, -1, -1, -900, 0, 1, sorry, 1, 0, 1, 0, 500, 0, 1, 0, 1, 1000, 6, 5, 4, 8, 1. Now we will write it back into the equation form. And all the constants will become in the less than equal form, and we write it in a new variable. Your profit will become like 700 y1, 900 y2, 500 y3, 1000 y4, and the constants will be -y1, y3 less than equals to 6, -y1, y4 less than 5, -y2 plus y3 less than 4, -y2, y4 less than. Now this is a problem of maximization. All the constants are in less than equal form and we are given a profit function. Now we add the slack variables like -1, y3 plus x1, it will become equals to 6, -y1, y4 plus x2, it will be equals to 5, -y2, y3 plus x3 equals to 4, -y2, y4 plus x4 equals to 8. Why do we add slack? Because just to explain it once again, like we know that 5 is less than 6. So how we can make it equal? We need to add a number here. Then they will be equal. What is that number? We need to know. Similarly, like 5 is equals to 5, but 5 is less than or equals to 7. So now we need to add here to make them equal. We don't need to add here. If we add it here, it will become even more bigger. So that is why we are adding it on the left side. So that is why we are adding here slacks, not on the right side. Now we write it back into the matrix form, which would be our uh, simplex method. So we write our variables y1, y2, y3, y4, x1, x2, x3, x4, and p. So it is minus 1 0 1 0 1 0 0 0 and 0 equals to 6, minus 1 0 0 1 0 1 0 and 0 0 5. Then 0 minus 1 1 0 0 0 1 0 0 4, and then 0 minus 1 0 1 0 0 0 1 0 8, and then 700 900 500 minus 1000 0 0 0 0 1 and 0. So this is the simplex tableau. Now our basic variables are x1, x2, x3, x4 and p. Why they are basic variables? Because in their columns, if you see here, we have 1 and rest of the elements are 0. Similarly for x2, x3, x4 and p. Now the most negative number in the bottom row is minus 1000. So this is our pivot column. To decide the pivot row, we cannot divide 6 with 0. We can divide 5 with 1. So it is 5. We cannot divide 4 with 0. So we divide 8 with 1. So the smallest quotient is 5 or 8. So smallest quotient is 5. So this is our pivot row. So y4 will enter into basic variable. Y4 will go into this position. With the help of this one, we will make 0 above and below. And when we do so, we will get minus 1 0 1 0 0 0 0 and 6. Minus 1 0 1 0 1 and minus 1 0 1 0 1 0 0 0 and the 0. Okay, then minus 1 0 0 1 0 1 0 0 0 and 5. Then 0 minus 1 1 0 0 and 0 1 0 0 and 4 1 minus 1 0 0 0 minus 1 0 1 0 and 3, and then last one 300 900 500 0 0 1000 0 0 1 and 5000. Now again in the bottom row we will see the most negative number is the only minus 500. This is our pivot column, and 6 divided by 1, 4 divided by 1, so 4 is the smallest quotient. So this is our pivot row. Now this is our pivot element. With the help of this one, we will make zeros above and below. So when we will make zeros above and below by applying all the row operations which are needed, so it will become minus 1 1 0 0 1 0 minus 1 0 0 2 -1 0 0 1 0 1 0 0 0 5 0 -1 1 0 0 0 1 0 0 4 1 -1 0 0 0 -1 0 1 0 3, and then minus 300 400 0 0 0 1000 500 0 1 and 7000. Now again we will apply the last operation. uh, so you can see this is the most negative number in the bottom row again, so we will decide the pivot row and pivot column, and at the end I just write it. Yeah, you can write the solution. This is your example 4 in the book. You can just go through from it, and if you would have any problem we can discuss it on live tutorials and on white. Otherwise we can discuss it on WeChat or wherever you feel comfortable.